Okay, well, why don't we kick it off? And there might be other people who join as we get going. But welcome everybody to an LF Decentralized Trust meetup. Today we have Hendrik Ebbers, who is going to talk to us about the new Hiero project. So with that, Hendrik, take it away.
Thank you. And thank you for attending the session. So if you have any questions, so who are currently live here in this call, feel free to put them in the chat. I will be happy to answer them live or afterwards. Okay, so yeah, I would like to talk about the new Hiero project that is now part of LFDT. I titled this presentation Open Source as a Factor of Trust because from my point of view, trust is the most important aspect here and the thing I would like to concentrate on when talking about Hiero. So maybe we start with some words about me. I'm Hendrik. I'm from Germany, live here in Dortmund, and I'm working on open source since several years. I'm a member of the board of the Eclipse Foundation. I work at several working groups and steering committees within the Eclipse Foundation, for example, the Adoption project. And now I'm part of the Linux Foundation too, as the lead of the technical steering committee of the Hiero project. I'm a contractor. I work for Hashgraph, which is one of the companies that is highly involved in the Hiero project, doing a lot of work on Hiero. Next to this, I have my own company, Open Elements, that is involved into all this Eclipse stuff. But today I don't want to talk about Eclipse or Adoptium. I would like to focus on Hiero. So to get into the topic, I would like to talk about distributed ledger technology in general first, to make a common understand what distributed ledger technology is, and especially how I think about it and what it means for me and where I see the real benefits about it, especially in combination with open source, which is, from my point of view, essential when it comes to DLT technologies. And based on all that, I will give an introduction to Hiero. So as you see, we don't start directly with Hiero. We start with a general topic first, talk about what is it in general, what is distributed ledger technology in general, and then go down to Hiero. Okay, so I often used it now. So what are distributed ledgers, right? So maybe you've never heard about that. And I always like to introduce distributed ledgers with a real use case, with a real world application that is, from my point of view, quite good, understandable for really everybody, for technical and non-technical people, and gives an overview what you can do with distributed ledger technologies. It's just a sample, you can do more, but I think it's a quite good sample. So as said, I want to talk about a real use case. And the real use case, so let's start with the background of that use case. So let's assume you live in South Africa, and you have a friend or maybe somebody out of your family who's living in South Korea. And what you want to do is you want to transfer money to that person. I mean, we live in a modern world, right? It's not that hard to do that. We can do that by doing a bank transfer, actually. That is how we transfer money nowadays. So when coming to banks, a good example here is the Standard Bank, which is the largest bank in Africa, and the Shinhan Bank, which is kind of leading bank in South Korea. And let's take those two as an explicit example, because what those two banks did, they did a research to check, okay, how is it if we want to transfer money from one bank, the Standard Bank in South Africa, to, like a different place on the world, to the Shinhan Bank, to an account that is at the Shinhan Bank, which is in South Korea. And what I found out is, really, for me, when I've seen the numbers, it was really shocking, right? I mean, you suggest, oh yeah, that costs some money, costs some dollars, and yeah, maybe it's not done like that. Maybe it takes like half a day or something like that. But in reality, the transaction fee is $40 or even higher. And even more worse from my point of view is that such transaction needs up to 6 business days. So I'm not talking about days here. I'm talking about business days wise, which means if you do start the transaction maybe on a Friday, it took way more than, or can take way more than 1 week until the money is on the other account. Having such a time for a transaction is especially problematic when the transaction cannot be tracked, right? You start a transaction on your side, set money somewhere, and for, I don't know, 7 or 8 days, you have no clue where that money is because it's not observable, it's not trackable. And you cannot just call somebody because with all that banks in different time zones and so on, the operation hours are really limited. So that was the outcome of the research that those 2 banks did. And here you see like a graph, an illustration, how a transfer internally works. And as you can see, it's not that there's a straight arrow from the Standard Bank to the Shinhan Bank. No. Instead of that, multiple other banks are involved in this transaction flow. So it's not only internally one transaction, it's like multiple transactions between multiple banks. And while those transactions now based on standards like SWIFT, within a bank to move it forward to the next bank, you have no insight what's going on there. It could be even like a manual process where in the morning somebody gets a list of all those incoming transactions and manually start like the next step of the journey. So we just don't know, right? We just only know several banks are involved. We cannot look into them, and it takes a lot of time. And so what the Standard Bank and Shinhan Bank did based on that, they created a small project. They created a POC, and that was released like, yeah, kind of a year ago. And they used distributed ledger technology, especially they used the Hedera network to create a software or a software solution that helps them to do those workflows, those transaction workflows faster. And in general, it looks like that. So both banks are interacting with the Hedera network, which is a distributed ledger. And what those 2 banks done, they created tokens like crypto coins, right? In that case, they especially created stable coins, which means that what a coin is worth is bound to a real world asset. For those tokens or for those coins, they used the South African rand and the South Korean won. So they created an internal crypto token that reflects the rand and one that reflects the won. And they created out of this token type, I don't know how many, let's say like some millions of coins, and then exchanged kind of half of it, so that both of the 2 banks do not lose anything, but have coins of 2 currencies in a digital way. And those are really like internal tokens, because on the Hedera network, which has some enterprise features, it's not able to, if you create a token like that, just send it to any other people. You need to assign accounts that are allowed to work with such tokens. So it was a really kind of internal solution here. And what they did is, when a transaction happened, they did those transactions by doing a transaction of crypto coins on the Hedera network, by reflecting the real transaction on the Hedera network. And by doing that, they were able to create the same transaction with a cost that was less, or that is less than 10 cents. And let me tell you something. Those 10 cents are not the cost on the Hedera network, actually, because the cost on the Hedera network for do those transactions is way less. That is already including the cost that those two banks put on top, given for their infrastructure and things like that. And the transaction happens in less than a minute. So on the Hedera network, it goes like that, but the other side need to observe and get notified when a transaction happens and so on. But they were able to do that in a nice flow. So they were able to do it with under a minute. And since the transactions happened on the Hedera network, which is like observable, where transactions can be tracked, you are able to do real-time tracking of the transaction that has been created for those money transfer. And it just works 24/7, right? Because the Hedera network is just online 24/7. So that is 24/7. So that is a real use case that is created on top of a distributed ledger technology. We haven't thought about what is it at all, right? We just now defined, okay, there is something I called the Hedera network, and both companies, the Shinhan Bank and the Standard Bank, interacted with that network. So let's go to the next step and think about why doing it like that makes sense. And this is exactly the point where the trust comes into play and where we see why trust is so important in those technologies and in our world today, actually. So let's start with a really simple example that we have every day. Let's assume we have two companies. I just called them here Company A and Company B. And those companies have a common use case and they want to share some data. So they want to share data between those two companies. So how can that be done? Sharing data between two companies. The problem that you always have with something like that is that you definitely need to have an owner of the data. And you can exactly only have one owner of the data. So why? Let's assume you have both companies and they exchange data, and the data, there's a conflict between the data in the two companies. Let's say like they share user data, and the user John Doe has a different address in the data entry in company A than it has in company B. So now the companies need to decide which is the address we will use, which is the kind of like real address. To define that, we need a kind of master, somebody that owns the data and that is in such case, like in a conflict of data, is the one who defines like how the data looks like. And I think you can imagine that, as we can see it here on the screen, with having being company A, the master of the data, can be a problem for company B. Because if somebody owns the data, that means that there is one single point of truth of the data, and that single point can be mutated. It can be either mutated by company A, which might be quite easy for company A, but it could even be mutated by hackers, right? Or even company B can try to mutate the data of company A to get the data into a way they would like to have it. And yes, things like that happened, right? And based on that, I think it's a bad idea if you have critical data and if you exchange critical data between companies and you cannot really define by the type of the data who is the master or the owner of the fusion, actually. So let's contain. Yeah, as said, if you do not trust each other, you have a problem. So how can we solve that, right? We have two entities that don't trust each other, but that want to share something. The easiest solution how we can do that is by externalize the trust, right? So we can hire a company, maybe like this Trust Inc. company, and say like, hey, are you able to be the master, the owner of our data? By doing so, neither company A or company B can easily change or mutate the data, because now it's in this example, the Trust Inc. that owns the data, and company A and company B can both work with them, can maybe copy them, clone them, but if a conflict happens, the data that is stored in this Trust Inc. is the trust or the data we will use to solve any conflict. Sounds good, isn't it? Maybe in the first moment, but by doing it like that, we again can end in a lot of problems. So if Trust Inc. owns the data, I think the critical question is, who owns Trust Inc.? And who controls Trust Inc.? Why do we know that in that case, the owner of the data does not mutate the data in a way that it's good for him? Or maybe offer one of those companies to mutate the data for money in a way as it is good for the company, right? So nobody knows if Trust Inc. is a super solid company, or maybe is a company that is just wants to have your data and get as much money out of it. And by owning that data, they can really change anything in general. And once a conflict happens, the fallback is exactly that one, which is, again, a big problem. And especially this problem, by having an outsider company that can, like act in a bad way regarding the data, at the end, something like that can happen. So it can really ruin the companies, it can destroy the business. So based on that, this like single point of failure, or this single owner of the data, looks like a big problem. And looks like that in those scenarios, that is not what we want. And let me go back, what we want is trust, right? And now I want to go a little bit more technical and talk about decentralized trust, because that is what Hiero and Hedera, that I showed as a sample, is all about. It's about decentralization. And decentralization, as if you studied like informatics or something like that, you might have learned it as university, is a kind of distributed system. So what you have is like multiple PCs, nodes, servers, however you want to call it. It's not defined. It's just some technical devices within one network. Today, we can just say within the internet, because that's the big network that we have. And those systems are somehow connected and somehow distribute data. The good thing on a distributed system is that it can scale, right? So you can make it bigger, you can make it smaller. And today we have a lot of distributed systems that are really huge, that really scaled to like being global systems with nodes all over the planet. And when talking about those distributed systems, there are two important facts that people learn at university, that you read in books, that you read online, which is, first of all, the scalability and then the fault tolerance. So fault tolerance means if I have a system like with that many nodes as we see here, and two of the nodes break down because they are losing power or something like that, the system will still work, because there are still nodes in the system that can distribute data. And the scalability means, and that is what you learn often when talking about distributed systems, that the more nodes or machines you put into a distributed system, the more power you have, the more load you can do. And Now comes one really important and critical point. When talking about distributed ledgers, that is not true. While the fault tolerance is 100% true, the scalability that people know from things like microservices, where you can easily add 10 additional nodes to a service, and then 10 times the customers can reach the service, like, I don't know, Amazon or other web shops do it on Black Friday. That is false for a distributed ledger, because a distributed ledger works different than, for example, microservice systems. So because on a distributed ledger, while it's a network as we've seen before, whenever a client does a transaction against the system, every transaction is handled by every node in the system. So while in a microservice framework, a transaction that goes in is handled by exactly one node, which means if you add more nodes, you can handle more clients. Here, it is the opposite. Each and every node communicates and handles each transaction, which means if you add nodes to a distributed ledger that do not make the distributed ledger faster, it just have the transactions that you send to the system be executed on even more nodes. And that is important, because what those nodes do is they define the trust of the system. Because if you have 20 nodes that do the same calculation and all get the same result, you know that the result is true. If you have just one node that does a translation and it gets a result, it maybe an error happened, maybe it run out of memory in the second step of the transaction, and based on that, the result is wrong. But it's not that likely if that 50 nodes who run the same transaction get an out of memory or something like that at the exact same step within the transaction. So having more nodes in a distributed ledger does not make the ledger faster, but make it more scalable. I think that is one of the most important facts from my point of view when talking about distributed ledger technology, which means we have scalability and we have fault tolerance. The difference is just that the scalability works in a different way. It don't make the system faster, it makes it more trustful. There are other important points when talking about distributed ledgers, like, for example, the consensus mechanism, because if you have, I don't know, 20 nodes in a network, and each transaction that, for example, is a calculation, is executed on each and every node, we need to create a consensus after the transaction to say, yeah, we are in consensus that this is the correct result of the transaction. That is what a consensus mechanism does. And there are different consensus mechanisms. You might heard about proof of work or proof of stake. I don't want to go deep into that today, because I want to give, a general overview about the topic. So that would be too technical for today. If you are interested in that, you can definitely ping me, and if enough people are interested, we can definitely do a presentation about that on the LFDT meetups too. Another important thing is transparency and immutability, because when having a distributed ledger, it needs to be transparent to see that the nodes behave correctly, right? And when talking about immutability, it means what happens on a ledger should not be changed, because if one node has a different state, the node will have a big problem. So the transactions that are going through such a ledger should be immutable. So that I just see there's a question of LinkedIn is a good place to connect with me. I have a slide at the end of the presentation with my LinkedIn contacts. And yeah, LinkedIn is a quite good place to connect with me. We already talked about Hedera. I don't want to talk that much about Hedera today, but I want to use it as an example of a decentral network of a distributed ledger. So Hedera is a network that is quite enterprise focused, and it uses exactly the technologies I just described. And the interesting thing that Hedera does is there is the Hedera Council, and you can see the members in the bottom of the page. You see like some big companies like Google, IBM, Dell, Boeing, and so on. And each of those companies execute exactly one node of the network, which means when you work or when you do like a transaction against the Hedera network, that transaction is executed by each of those companies exactly by one node, which means if you want to harm that network, more than 50% of those companies would need to work together and manipulate the data together, right? And that is, will not happen, to be fair, because look at that companies. That is absolutely not a realistic scenario. Which means if we come back to our example, what two companies can do is they can interact with a distributed ledger network, because by doing so, the trust is not on one central place, but is distributed by all the nodes that are part of the network. Even better, what companies can do, they become part of the network and run a node on its own to verify that the state is valid and to, verify that everything is working nicely. That is what you can do with distributed ledgers. And while that is from a presentation point of view quite obvious and works quite nice, there are some pitfalls when creating such a network you need to think about to really make it trustful. One point is open source. So how to trust a network? One point is the network or the source code of the network need to be open source, because only by having open source, it will be auditable, right? I, as a customer, will not have a vendor login. I can fork it in a worst case. But I think for a network I want to trust on, the most important point is that if I want, I can audit the code, or I can look at audits happen maybe by some other large companies, big businesses, or foundations like the Linux Foundation, for example. And that is really super important. Another super important topic when it comes to the trust of such a network is the supply chain security. And especially the Linux Foundation is doing a lot when it comes to supply chain in the open SSF. And what you see here in the bottom is like a super basic diagram how a supply chain looks like, right? You have source code, and the source code get built, and out of the build you get a package, an artifact, whatever. And when talking about supply chain security, each and every step in this chain need to be secured and should not be harmable to not create a network that is broken, where maybe in a worst case, all nodes of the network coming from the same distribution are broken. And when looking at that supply chain, there are really a lot of attack vectors. Like here you just see the points where attacks can happen. I just added some examples, starting with somebody submit unauthorized changes up to somebody compromises the package registry. And you might say, yeah, that is, no. I trust open source, that is fine. Those things are happening. I mean, when you just look at the last years, how much press we had about security holes in open source, that is really a problem. I mean, it's even better than in closed source, right? But we need to take care of those security supply chain security topics. Happily, when it comes to open source, there are two really great players about it. First of all, the OpenSSF from the Linux Foundation that has a lot of good documentation about supply chain security that provide like checks for security that you can add to your open source repositories and so on. And next to the Linux Foundation, the Eclipse Foundation now started a working group where a lot of other foundations like the Apache Foundation, the Rust Foundation, the PHP Foundation, and so work together to create best practices for supply chain security, especially with the Cyber Resilience Act in mind. And all that is needed for a trustful network. And with everything I now talked about in mind, I would like to switch and be more concrete and talk about Hiero and the Hiero project now. So what is Hiero? Hiero is a new project of the Linux Foundation Decentralized Trust that has been announced this September. So like 2 months ago, like I think it's like really mostly 2 months ago. It was on the 19th maybe of September. And now you might see why I used Hedera all the time in my slides as an example, because what we are doing with Hiero is removing the sources of the Hedera network to the Linux Foundation to create a vendor-neutral base for decentralized networks. So what does that mean? It means that the whole source code of Hedera, so wherever it makes sense, we're not talking about the configuration of the nodes, right? This don't make sense. But really, the source code that is used to create the consensus nodes, so the nodes that are running in all those companies, the SDKs, and so on, is or will be transferred to the Hiero project with the goal to have Hiero the first really fully vendor-neutral and open source distributed ledger technology. And I think that is a real important and big step because that allows companies, big companies, governments, and so on to rely on something that is vendor neutral, that is created by big players in cooperation under the hood of one of the, or the maybe biggest open source foundation of the world. And that is a huge success from my point of view. So what is it when we look into Hiero? So the Hiero landscape. As I already said, in general, what we're currently doing is we transfer the source code from Hedera to Hiero, and that is ongoing. So like 20 hours ago, the Go SDK has been transferred from Hedera to Hiero as an example, and I expect that this transfer will even take some time. So I don't assume that we are fully done with this transfer end this year, because the transfer does not mean that we just transfer the repositories to Hiero. It means that we even make the code vendor neutral, right? So we from time to time have classes or packages in the code that have Hedera in its name. We want to change that. The SDKs has assume that you run with an Hedera network and have all this by default reconnect to Hedera. We need to change it. It makes sense to have the connection configurations for Hedera still in the SDKs, but it should be more open, because with having everything under Hiero, it allows you and everybody else to run a Hiero network. So right, Hedera is and will be the big public ledger that is run by all those companies we've seen. With a move to Hiero, any university can easily set up its own Hiero network and have the students play with it, or even have the students run and maintain a node. Companies can come together and create their own private network. If you, for example, like a big car company and all your suppliers that like for every small part that you need in a car need to send you like test contracts and stuff like that, you could set up a network based on Hiero where each of your subcontractors and you run one node and store all those information into that network. And then nobody will ever be allowed to change the test results of that. That is a huge step in the right direction, even to help smaller companies to not being that much dependent anymore on all these big companies. So we have a metrics. It's open source. It's in the GitHub repository of Hiero. It's called the GitHub repository is Hiero Ledger. I just put a screenshot here that shows a part of this metric where you can see like for each and every repository what has been done and where we are currently working on. There are a lot of steps that need to be done for each and every repository to be fully migrated to Hiero and to be fully vendor neutral. And as said, we are working currently exactly on that. And once we are done, there will be a lot of projects, different repositories and projects under the Hiero project. Let's have a look at those. So I would like to start with the consensus node, because the consensus node is a software that runs in the network, that runs on each and every node of the network, and together defines the distributed ledger. The consensus mechanism and all that is part of it. And it's exactly the same source that is today executed within Hedera, right? So Hedera in future, so we are not forking it, right? So we move the source code to Hiero, which means Hedera will in future use the Hiero releases and run them in their mainnet. Yeah. But it means again that every other network that is based on Hiero will be compatible to Hedera, right? You can access it in the same way, independent if it's the Hedera mainnet, if it's a small ledger in a university or a private ledger within, different companies. You can interact with it in exactly the same way. To show how we are connected to other projects within the Linux Foundation, and especially the Linux Foundation of Decentralized Trust, the consensus node runs internally Bizu, which is a huge other project of the Linux Foundation Decentralized Trust, which is, now I get really technical, an EVM implementation, which is the Ethereum virtual machine, which means by having that integrated in our consensus node, that we are compatible with Ethereum, which means every contract that you can run on Ethereum and install in Ethereum can be installed on any Hedera-based, or sorry about that, on any Hiero-based network. On top of that, we have some other server components. I put down here the block node, the Ethereum RCP relay, and mirror node. So the block node is a node where we externalize our block stream that contains the transactions to make that one even standardized and better accessible to third party. The Ethereum RCP relay is something that you can run on top of the consensus nodes, and it's a wrapper around the consensus node services and API that it uses all the Ethereum APIs, which means that once you have the Ethereum RCP relay running for your network, mostly every Ethereum client can be used to work with a Hiero-based network. As an example, another project of the Linux Foundation Decentralized Trust is Web3j, which is like the most common Java library when it comes to connect and interact with an Ethereum network. You can, with the running Ethereum RCP relay, use that client library to interact with an Hiero network. You do not even need an Hiero SDK. You can even use that. And last but not least, on the server side, the mirror node, which is a special kind of node that is encapsulated from the consensus node and that provides APIs to query the data and the state of the network. You can query transactions, you can query tokens, and so on. And by having that externalized, you have the huge benefit that you do not need to do a transaction against the network, which means you do not need to pay for it. And you can use things like standardized REST calls against a mirror node to, for example, get all information about a token or a specific transaction. That is, for example, what a lot of software use as a backend when they show information of Hedera today in a web front end. They just call REST endpoints on the mirror node. On top of that, I now created a layer with all the things that are not running on the server, which are all our SDKs. Currently, we have those SDKs, C++, JavaScript, Go, Java, Swift, and Rust. But with Hiero, we have the possibility to add more. So those were the SDKs that are officially supported by Hedera, right? And they will all be transferred. But with Hiero and having the community and having different parties coming together, the chance to have additional languages or to have additional SDKs in different languages is quite high. To be fair, I had last week meetings about adding a Python SDK to Hiero, and the chance to have that in near future is very, very high. I haven't put it here because it's not official now, but I can already say it here in this stream. My assumption is that we will have a Python SDK as the next one, which is then not coming from Hedera, but coming from the community, which is, from my point of view, a great success. Then we have the Explorer, which, as said, it allows you to explore and view things like transactions, tokens, and so on in a web front end, in a web UI. It uses internally the mirror node, connects to the mirror node to show all this data. And very important for developers are Solo and Local Node, because those are two projects that allow you to run a local instance of a full Hiero-based network. That means that you can use that, for example, in integration tests, to set up a network, run your tests against it, and then shut the network down. If you are technical, I, for example, do this now with all things I do with GitHub Action. I've created a GitHub Action that I assume will be transferred to Hiero 2 that allows you to, for your unit and integration test, just set up a full network. You can run your test against it, and then the network is shut down. That is quite nice and makes development based on a distributed ledger, which is normally quite complex, super easy. And then on top of it is what I hope to become next. This is what I hope is created by the community. So not only by Hedera and the people from Hashgraph that currently create, or Lime Chains that currently create the things for Hedera, but other companies that want to use Hiero as a private network, that now, since it's vendor neutral, maybe even say, okay, let's start by using Hedera, and that all together can create the next layer on top of it, like wallets, like integration into enterprise frameworks like Spring or React or whatever, like important dev tools that are needed. I already talked about this GitHub Action I created. That is a good example for a dev tool. So that is what I hope comes next on top of what we currently transfer from Hedera to Hiero. And when talking about we, a lot of people are involved. A lot of developers currently work on Hedera, and some of them, and I'm one of those lucky persons, have been nominated to form the technical steering committee, which today leads the development within Hiero, which at the moment mostly means leading the transfer of all the Hedera stuff into Hiero and make everything available to have third-party projects on board and get into Hiero. So those people come all from different countries, come from different companies. I think it's a good start already for TSC, But my hope is, and it's not only me, it's from all the other members of the TSC too, that we get way more diverse in future. So we have open seats on the TSC where we hope in the future to have some other people from the community that are not coming out of the Hedera ecosystem, even maybe, being part of the Hiero TSC. When talking about the TSC, based on what I said, there are in general three like main topics we're currently working on: transferring all the Hedera projects to Hiero, onboard new projects to Hiero, like I said about the Python SDK, and create a diverse and inclusive community. Not only on the TSC, where I would really like to be more diverse in the future. I'm even talking about the community at all, and I all invite you to attend our TSC calls if you are interested in that, because they are open. Everybody is welcome to attend them, or to attend our community calls where we discuss all these topics, present projects that we want to onboard, get feedback from the community, and so on. So I hope to see some of you in near future on one of those meetings. So that's about Hiero, and let me take like the last 2 or 3 minutes to recap that and put all those pieces together. What does it mean, right? So, which means I come back to those 2 companies, to my favorite example. Having those 2 companies that want to work together and exchange data, we learned it would be wrong to have a direct connection, to have one master or something like that. Instead, today, with the technology we have today, those 2 companies can exchange data over a decentralized network. One example could be Hedera, where you have over 30 entities, companies, and I just put random examples here: Google, Deutsche Telekom, Standard Bank, whatever, companies from all over the world, from different sectors. That's why I choose those examples. And trust that network and put all your data onto that network. If you want to be more private, while it's totally open source and now under the Linux Foundation, what you can do, oh, and sorry about that, I missed the supply chain security under the Linux Foundation. What you can do is you can even use it and set up your private networks for this. While maybe with 2 companies, it's not that perfect, but in theory, it would even work to set up a network with 2 companies. Best is if you have like multiple companies that exchange data, then you can really use that to set up your network and create a trustful way how to exchange data, which means, from my point of view, as I said at the beginning, for me, it's all about trust. What does it mean? It means transparency is important. Transparency is trust. Supply chain security, super important. It's trust. Decentralization creates a lot of trust, as does vendor neutrality that we now have with being part of the Eclipse Foundation. The community creates trust, because if several people work together and think the same, it's quite hard to be the bad guy inside of a good community, because you have a lot of collaboration that creates trust in an open source environment where everything is open and transparent. How can something be more trustful than that? Which means, and that is where I would like to end with, for me, the Hiero Ledger and the Hiero network project creates a lot of trust and will help you to create trust with your partners, with your enterprises, and exchange data in a really trustful way. As said, that is my last slide. And as I said, if you want to connect with me, easiest way is to use LinkedIn. You see my LinkedIn name here on the bottom, or you can just do a screenshot of the barcode to connect with me. And yeah, it's the hour is mostly done already. Oh yeah, that took time. So I hope you liked that presentation. I hope it was not too technical. I hope it was not, less technical. If you are interested more in the technical side, I'm currently preparing my next presentation that I will do on the LFDT meetup, which is about the SDKs and how to use the SDKs to work with an Hiero-based network. Yeah, so are there maybe any questions about my presentation, about Hiero, about decentralized networks? So there's a question about an IBC Cosmos integration, and if there are any plans for that. So actually, I'm not an expert in that topic. I don't know anything about it, which don't mean that there are not already discussions, because I mean, as you might assume, starting with consensus node over the other node we have over the SDKs up to the wallets, there is so much. Then you have like this solo nodes that help you to set up a network. This is a so big topic that I still have problems with getting into all those different topics. I'm currently trying to concentrate on this, how to use SDKs, how to create application with it, especially in the open. So about IBC and Cosmos, I cannot answer that question. But if you are interested in that, you can ping me and I can forward that question to one of my colleagues, actually. Okay, any other questions? Okay, looks like there were no additional questions. If you have questions later, feel free to ping me. If you have technical questions for the Hiero project, we have GitHub discussions activated. So if you're a technical person, you can easily ask any question on GitHub in GitHub discussions or GitHub discussions on the Hiero Ledger org, or you can ping me on LinkedIn and ask me any question. If I cannot answer it, I will definitely forward it. Okay, so thanks again for your time. I hope this presentation was helpful to you, give you a good introduction about in decentralized technologies, DLT, and especially in Hiero. And maybe see you on the next presentation, which I assume will be about SDKs. Oh, I see there are some things coming on. Oh, there's a question about the recording. As far as I know, yeah, it's recorded. Yeah, it's
I'll
available.
send the link around.
Yeah,
I'll
yeah,
send some resources out to everybody who signed up after this. I'll put a link to the recording and the repo and the calendar and some other stuff. So look for that. But yes, the recording is on the LFDT YouTube channel. It's been live streaming, and that's where the same link for the recording after this.
perfect. Thanks, David. Okay, so if there are no additional questions, thanks for having me, and see you somewhere in the community. Bye.
Great. Thanks, everyone.